Lesson 14 through 16, notes, solving systems by elimination. So in this lesson, we're going to use these three properties of equality, which we've been using to solve equations. We just haven't talked about their official names, official algebraic names. So the first property is the addition property of equality, and we use this when we're solving for x in this situation. We have x minus 4 equals 15. To get x by itself, we would add 4 to each side and get x equals 19. And the justification for this is the addition property of equality. And what it says is that when one thing equals another, when A equals B, so we could say like this is A, and this is B, then you can add the same thing to both A and B, and both sides of your equation are still equal. So in this case, this C that we added, the same thing, was 4. We added 4 to both sides, and it was still made an equal equation. We use the subtraction property of equality when we solve a problem like this, where we subtract the same thing from both sides to get x equals 8. So same thing here. This is like our A, and this side is our B, and we're subtracting the same thing, in this case 5, from both sides. And because we did the same thing to both sides, and the two sides at the beginning were equal, the two resulting sides, x and 8, are also equal. And then the last is the multiplication property of equality. It says when one thing equals another, you can multiply both of those sides of the equation by the same thing, by c, and they're still equal. So we would do this, x divided by 4 equals 7. To solve that, to get x by itself, we would multiply both sides by 4. On this side, the 4 would cancel, and we would get x equals 28. We're going to use those properties in solving systems by elimination. So here we have a system of equations. We've solved these systems two other ways before. So a system of equations is two or more equations. In this case, these are linear equations. If we were to graph them, they would be lines. We've solved these so far in lesson 12. We solved them by graphing. We graphed each line, and we saw where they intersected. And then we got the coordinates of that point of intersection, x comma y. We found the solution that way. And then in lesson 13, we solved by substitution, where we solved one of the equations for a variable. So let's say we went through and we solved this, and we got y equals something. We got y by itself. And then we could take that something and substitute it for the y in the second equation, so that we only have x now in the second equation, and we can solve for x, then go through the steps, plug it in, and find our y. Now we're going to learn a new method, and that is the elimination method. So we have the steps written here on the right. And we're going to, the first step tells us that we might need to multiply one or both of these equations. We're going to hold off and do that on the next page. This particular example, we don't need to do step 1. So I'll just write here, step 1 not needed, and we'll see why in a little bit. Step 2 tells us to add both equations together. So what that means is we're going to add the x's together, we're going to add the y's together, and we're going to add the integers together. And the reason we're allowed to do this is the addition property of equality. Here we have our a and our b, right? One side equals another, like up here. And then we're adding the same thing to both sides. So it doesn't look like the same thing. Negative 4x plus 2y does not look like negative 30, but because it has an equal sign in between, it is equal. So that is allowed. We're adding equal quantities to both sides, so we can still say the resulting equation is equal. So let's see what that looks like. I'm going to erase a couple of my lines here. All right, so we're going to add both equations together. We're going to add like terms. 4x plus negative 4x is 0x. 8y plus 2y, positive 10y. And then 20 plus negative 30 is negative 10. So this 0x is just nothing, right? It cancels out. I'm just going to put a little arrow through it. It goes away. And we're left with 10y equals negative 10. To get y by itself, we're going to divide both sides by 10, which gives us y equals negative 1. All right, so we have solved for part of our solution. Our solution is an x and a y. It's the point where if we were to graph these two lines, the coordinates of their point of intersection. So we have the y. Now we're going to use step 3. We're going to plug our solution to the variable in step 2, in this case we did y, into one of the original equations and solve it. So I'm going to take this first equation. You could do either one, doesn't matter. And I'm going to plug y into that equation. So I have 4x plus 8. Now instead of writing y, I'm going to plug in what my answer is for y. And this is helpful because now we only have one variable to solve for. We can solve for the x. So that gives us 4x minus 8 equals 20. We can add 8 to both sides. And I get 4x equals 28. Divide both sides by 4. Get x equals 7. All right, I have my solution. X is 7, y is negative 1. I'm going to write that as a ordered pair, right? Because it's a point, the point of intersection of those two lines. And now I'm going to check my answer by plugging this point into the other equation. So the second equation, we used the first equation to solve for x. We're going to use the second equation. I'm going to plug it in. So our second equation is this. And I'm going to plug in my x and my y to this equation. So that will become negative 4 times our x, which is 7, plus 2 times our y, which is negative 1. And we're going to ask ourselves, is this true? Is this going to equal 30? If it is true, that means that we have solved correctly. So this gives us negative 28 plus negative 2. Is it true that negative 28 plus negative 2 equals 30? Yes, it is. So we can be assured of our answer. Okay, so now we're going to try some examples. Okay, let's see. Here's an example. Okay, I'm going to do this one. Now, again, if I add, I'm looking at my coefficients for my x's and my y's. It looks like my y's have the same coefficient. They're both 7y, but one is positive and one's negative. So that's good. That means I can add them together and it'll disappear, right? So let's try that. Let's see what happens here. 5x plus 0.5x is 5.5x. 7y plus negative 7y is 0y. 64 plus negative 9 is 55. The 0y will just disappear. And we'll get 5.5x equals 55. Divide both sides. I get x equals 10. Okay, so in this example, we did not have to do step 1. We'll do an example like that in the back page. Step 2 was adding both equations together and solving for the remaining variable. So we add them both together and the y's disappeared, so we solve for x. Now we're ready for step 3. Step 3, we're going to choose one of the equations and plug in our x and solve for y. So I could choose either equation. I'm going to go ahead and choose the first. 5x plus 7y equals 64. I'll plug in my x equals 10, so 5 times 10 plus 7y equals 64. I'll go ahead and solve it. Subtracting 50 from both sides, and I get 7y equals 14. Divide both sides by 7, and I get y equals 2. All right, so our point is 10, 2, and now we're going to check and see if that is right. So we're going to plug it into the second equation, this equation right here, to see if it's true. So that will be 0.5 times our x minus 7 times our y. Is it true that that equals -9? Well, let's see, that would be 5 minus 14. Is 5 minus 14 equal to -9? Yes, it is. So we can be confident that our answer is correct. All right, you're going to try this one now on your own. So we're looking good here. It looks like if we add these two equations together, the y's will disappear. I'll give you a hint here. One of our coordinates, either x or y, is not a whole number. It's going to be a decimal, but that's okay. The solution can have decimals in them. Okay, let's go to this next page now. Now we're going to look at a problem here. We have our x variables have the same coefficient, but if we were to add the two equations together, I would get this, which is fine. That's mathematically still correct, but it doesn't help us. It didn't eliminate one of the variables. We still have x and y, and we cannot solve for either one with both of them in there. So when you have two equations that have the same coefficient, but not opposite signs, you can, instead of adding the two together, we can subtract. We're going to use subtraction. So that means I'm subtracting 2x minus 2x is 0x. And we have to do subtraction all the way across. 3y minus 4y is negative 1y. 5 minus 9 is negative 4. So the x disappears. And we get negative 1y equals negative 4. We're going to divide both sides by negative 1. We get y equals 4. Plug that into one of the equations. I'm going to just go ahead and plug it into the first equation. So 2x plus 3 times 4, substitute in 4 for y, equals 5. 2x plus 12 equals 5. And we get, subtract from each side, and we're going to get 2x equals negative 7. Divide both sides by 2. Here I'm going to get a decimal. X equals negative 3.5. That's okay. We're going to now see if this point, negative 3.5 comma 4, we're going to check to see if that's correct by plugging it into the second equation. So let's see here. It's 2 times negative 3.5 plus 4 times 4. Is that equal to 9? Let's see. 2 times negative 3.5 is negative 7 plus 16 does equal 9. Yes, okay, I can be confident that this is the solution to the system of equations. You'll try this one on your own. This will also use subtraction. Now we're going to do one where we need to, where we're looking at our coefficients, and we see that neither of them are going to disappear if we add or subtract. So we need to multiply one of the equations by something so that when we add or subtract the two together, it will disappear. So I have a choice what I want to multiply by. I'm going to multiply this second equation. I'm going to try to get rid of the y. So I'm going to multiply this by 3. And the new equation, we're allowed to do that as long as we do the same thing to both sides by multiplication property of equality. So I'm going to distribute that 3 to each term. I'm going to get 3x minus 9y equals negative 18. And then my other equation is here. I don't have to change that because look, Now we have a situation that's going to be good. When we add it together, the y is going to disappear. And so then we just go about like we've done all the other ones. So for this particular one, we did have to do a step 1 where we multiplied one of the equations by a number. And then we just go ahead and we do step 2 like we've been doing, adding the equations together. This will be negative 1x. The y's are going to disappear. This will be negative 9. Divide both sides by negative 1. X equals 9. So you can go ahead now, plug that into one of the equations. It doesn't matter which one, whichever of your choice, and solve for y. Solve for y. And then we'll do step 4. That will be step 3, right? Solving for y. Step 4 will be checking it. Okay, the last example here, there's not a number we can multiply one of the equations by to make the coefficient of one of the variables equal to the other. So we're going to actually have to multiply both equations. So you have some choices. There's not one right answer for what you multiply. Let's say I want to get the x's to disappear. In that case, I would multiply the top by 5 and the bottom by negative 3. That could work. Let's see what happens there. So then we're going to distribute this 5 across to all 3 terms, and we get 15x minus 10y equals 10. Notice that we had to multiply that 5 times every term, and then we're going to distribute that negative 3 all the way across as well. Negative 15x plus 15y equals negative 30. So now we're in a good situation because look, these x's, when we add these 2 equations together, the x's are going to disappear. So here we used step 1, we multiplied both equations by something. I'm going to let you finish the rest of this on your own. And of course the other problems as well, number 4, number 2, do those on your own. I will check them when I do the next binder check. The last thing is a word problem. How fun! Elena and Kieran are playing a board game. After one round, Elena says, "You earned so many more points than I did. If you earned 5 more points, your score would be twice mine." And Kieran says, "Oh, that's not true. I don't think so. I only scored 9 points higher than you did." If both people are correct, how many points did each score? We're going to use a system of equations because we have 2 variables. We're going to say Kieran's score is x and Elena's score is y. And what we're going to do is we're going to take these key phrases here and we're going to make an equation for each one. So this is, Elena said, if you earned 5 more, so you, she's talking about Kieran, so if Kieran earned 5 more, so I would pause the video if you want to give yourself a challenge and see if you can write an equation for each of these. So if Kieran got 5 more points, his score would equal twice Elena's, so 2y. So there's one equation. I'll write that down here. The other equation is Kieran saying, I only scored, so he's x, only scored 9 points higher than you did. So you could say Kieran's score equals 9 more than Elena. So we have 2 equations. Now we have a system of equations. And we could solve it by graphing, we could solve it by substitution, or we could solve it by elimination like we've been doing here. Substitution might actually be a really good choice because one of the equations is already solved for a variable. I could substitute 9 plus y in for x and then solve for y. Since we're doing an elimination notes, how would that work for elimination? Well, I would set my 2 equations up. Here's one. And then my second equation, I would make sure it's set up the same way. So I would want x and my number on the same side. So I'm going to actually subtract 9 from each side and rewrite that equation as x minus 9 equals y, because we want our like terms lined up. Now, a good idea here would be to subtract, right? Because these are both 1x, but they're both positive. So if we added them, that wouldn't be good. It wouldn't disappear. We want one of the variables to disappear. So we're going to subtract. 1x minus 1x is 0x. 5 minus negative 9. Let's think about what that would be. 5 minus negative 9. That's the same as saying 5 plus 9. So that's 14. 2y minus y. 1y is just y, or 1y. The x disappears. So we get y equals 14. Elena's score is 14. Now I'm going to let you continue to solve that to find Kieran's score. So find x. Okay, that's it.